Today's lesson for Tuesday, April 21st is to balance the equation for cellular respiration. Yesterday we did it for photosynthesis. Now we're going to do it for the evil twin, which is cellular respiration. And as you can see in this chemical equation, the equation is unbalanced. How can we tell? Well, just look at the glucose going in. We have 6 carbon atoms going in, but what's coming out is only 1 carbon atom coming out. So we need to balance this equation in order to make it proper. So once again, this is LS 1-6, 1-7, balancing equations. This will be on your quiz on Friday. And the objective yesterday, we did the photosynthesis balancing equations. Today we're going to do the cellular respiration balancing equation. And of course, it's GLO number 3. Hopefully, after yesterday's practice, this should be a little bit easier. It's the same process. All right, so let's talk about the evil twin. So photosynthesis is the one that creates glucose, and cellular respiration is the one that breaks down glucose. Remember that this is how plants and animals get energy from glucose. It happens in anything that has mitochondria. It's a series of chemical reactions that breaks down the glucose and creates ATP energy. And here's a review of the cellular respiration. We have glucose going in, C6H12O6. We have oxygen going in, that's why we breathe. And then 3 things come out: carbon dioxide, water, and ATP energy. And this happens in mitochondria. So we have to figure out how many carbon dioxide molecules come out, how many water molecules come out in order for this to be balanced. And here is, once again, the unbalanced equation, C6H12O6 plus oxygen going in. So those are reactants. And then what's coming out is CO2, H2O, and then the ATP energy. We're not going to count this. It's considered energy. All right, so what you're going to do is you're going to go to Google Classroom, to the page 62 worksheet, and you're going to follow along. So when you go to Google Classroom, you'll see in week 4, there's a link to the page 62 worksheet. So if you click on that, you will then see the second part, which is for cellular respiration. What I did was I drew a diagram here to show you that it's unbalanced. The reactant side has 1 glucose molecule here, 1 molecular oxygen molecule here, and on the product side we have 1 water molecule here and 1 carbon dioxide molecule here. So we need to balance this out. So the first thing to do is you want to count how many atoms of each element you have. So let's just try here for glucose. We have C6H12O6. So how many carbons do we have? Well, C6 means there's 6 carbons. Are there any other carbons here? I do not see any. All right. Oxygens. Oxygens are a little trickier. We have in C6H12O6, we have 6 oxygens here. We have 6. But then over here we have 2. So 6 plus 2 is 8. So we have 8 oxygen atoms. Lastly, let's do the hydrogens. Well, we have 12 hydrogens in glucose, but none over here, so we have 12. Similarly, we're going to do the product side. On the product side, how many carbons do we have? Well, the only molecule here that has carbons is CO2, right there. So how many carbons do we have? Well, we only have 1. That's not enough. What about hydrogens? Well, the only molecule, what about oxygen? Well, both of these have oxygen. Well, we have 1 oxygen here in H2O, and we have 2 oxygens here in CO2. So 1 plus 2 is 3. So we have 3 of them over there. And lastly, how many hydrogens do we have? Well, we have 2 hydrogens in H2O, but no hydrogen over here, so we have 2. And as you can see, the carbons are not balanced, the oxygens are not balanced, and the hydrogens are not balanced. Once again, the suggestion is to ignore the oxygen. Do that one last. And the reason why is because oxygen is in multiple molecules. It makes it really complicated. So let's do the carbons first. We have 6 carbons going in, but only 1 coming out. And that doesn't make any sense. So we need more carbons. So where can we get more carbons from? That's correct. We have the CO2 here. So some people might think we need to put a 5 here because we need 5 more. But then if you count the carbons, if we have 5 carbon dioxides, that's one carbon atom per carbon dioxide. 5 carbon dioxides would be 5. That's not balanced. Instead, we need 6. And so if we have 6 carbon dioxides, then that gives us 6 carbon atoms. But that also changes the number of oxygen, because now we have 6 carbon dioxides, and 6 times 2 is 12. But don't forget that water still gives us an oxygen here. So 12 plus 1 gives us 13. All right, so it looks like our carbons are balanced. Next, once again, let's skip oxygen for now. Let's go to hydrogen. We have 12 hydrogens going in, but only 2 coming out, and that's impossible. We need more hydrogens coming out. So the only way to get more hydrogens is to have more water coming out. So how many water molecules do we have? Well, let's try 6. So if we have 6 water molecules, each water molecule gives us 2 hydrogens, so 6 times 2 is 12. Hey, that looks pretty good. But we added some more oxygens, so let's recount the oxygens. Well, each water gives us 1 oxygen atom, so 6 times 1 is 6. And then each carbon dioxide gives us 2, so 6 times 2 is 12. And that gives us 18 oxygen atoms. So our carbons are balanced, our hydrogens are balanced, but our oxygens are no longer balanced. We created too much oxygen on this side, so we need more oxygens to go in. Now, please do not give us more glucose, because that will give us more carbon, give us more hydrogen, so don't touch that side. Instead, we need more oxygen going in. So far, we have 6 going in and 2 going in, so we have 8. So we need more oxygens. Why don't we do it this way? We have 6 going in plus 2 going in, right? Now, we don't want any more glucose, so we want to keep this 6 the same. So we actually want to have 6 plus 12, right? So 6 from the glucose and 12 from the molecular oxygen. So if we want 12 oxygens going in, well, how many oxygen molecules do we need? That's correct. We need 6, because each oxygen molecule gives us 2. So 6 times 2 is 12. Each glucose gives us 6, so we'll put a 1 here. And 6 plus 12 gives us 18. And voila, carbons are balanced, oxygens are balanced, hydrogens are balanced, and here is our balanced equation. All right, here you go. Here's our final balanced chemical equation for cellular respiration. For every 1 glucose molecule, we need 6 molecular oxygen molecules to go in, and that will result in 6 carbon dioxides coming out, 6 water molecules coming out, and ATP energy for the cell to use to do all of its functions. And of course, I found a song that gives us the answer. See you tomorrow.
In your body, cells turn food to energy. Glucose from the food you ate, oxygen you breathe in, ATP energy. Release carbon dioxide when you breathe, creates water when complete. 3 products total with ATP energy. C6H12O6 plus 6O2 forms into 6CO2 plus 6H2O plus energy as ATP.